Hello and good day, pre-algebra. Today we are covering PO10 from La Casa del Schultz. We spent the last couple days looking at how to add and subtract rational numbers, focusing on integers, decimals, and fractions. Today in PO10, we'll look at how to multiply and divide integers and fractions. Okay. So for integers, we're looking at the sign of the number to determine how it's going to affect our product. When we add and subtract integers, we look at the operations to tell us whether we'll be going right on the number line or left on the number line. Remember that there are different ways to write addition. We can just use the plus symbol, or we can subtract a negative. Both of those mean the same thing. And there are different ways to write subtraction. We can just write a minus sign, or we can add a negative. Both of those mean the same thing. With multiplication and division, it's more straightforward. Okay, there's basically there are a few ways to write that we're multiplying, but it's very clear that we are multiplying. One of those ways is the dot. You see that used here in 8 times -3. Another one is just parentheses with the 10 and the 6 right next to each other there. If there's no symbol written, no operation written, it's understood that we are multiplying. And those are the only two that I've got demonstrated here. For division, we got that division symbol. That's pretty much it. Nothing too fancy. So for multiplication and division, we're looking at the signs of the numbers. You'll notice here, I've got a lot of negatives thrown in. When you were in 3rd grade, 4th grade, first learning how to multiply, if you look at multiplication tables that you've had on your desks through elementary school, all the numbers are positive. Okay, and you're used to taking a positive. Let me put this in. Let me be fancy here. I want to put this in red. There we go. You are used to a positive number multiplied or divided by. I suppose I have to do it again, don't I? Oh boy. Another positive. Look at that. My handwriting has never looked better. A positive multiplied or divided by a positive is going to be a positive. That's what you grew up with. You're kind of familiar with that. It's what you're used to, and so that's pretty standard. Okay. The other time you are going to get a positive, I'm gonna hold on. We're gonna make this faster here. We're gonna do this. And then this, and I noticed here, if I do this, I can just click on it right there. Look at that, technology, yes. The other time that you'll get a positive is when you take a negative multiplied or divided by another negative. That will also result in a positive product or positive quotient. And the reason for that, is kind of similar to subtracting a negative is actually meaning addition. Those negative signs essentially cancel out, just like a double negative would in a sentence. So positive times or divided by a positive is a positive result. A negative times or divided by a negative is a positive result as well. So when do you get a negative answer? Well, if you have a positive times or divided by a negative, that will give you a negative answer. And because we can multiply things in any order, here we have 8 times -3. Notice our positive comes first. We're multiplying a positive by a negative. And down here, we have -3 times 7. This time the negative comes first, right? Our answer is still going to be negative, because that -3 times 7 can also be written as 7 times -3. It's still going to equal a -21. 8 times -3 can also be written as -3 times 8. It's still going to be -21. So a negative number multiplied or divided by a positive number is also going to result in a negative answer. So general rule of thumb here, take a look at when. Ooh, that's not what I wanted to do. Hold on. Take a look at when we get a positive answer. It's kind of like fill this table. Anyone know how to fill? You're all probably telling me shading. Does this work? There we go. Yeah, that's what I want to do. When we get a positive answer, notice what is true about the signs of our numbers. They're the same, right? Positive, positive is a positive. Negative, negative, also positive. When we get a negative answer, hold on, where'd I go here? Design, shading. We'll do this in green. Packer colors. When you get a negative answer, it's because your signs are different. Doesn't matter which one comes first, positive, negative, negative, positive. They are different signs, and so you get a negative answer. Okay? So that is your crash course on integers. The actual math stays the same. I mean, negative 27 divided by 3, if you know what 27 divided by 3 is, you know it's going to be 9. Just now the question becomes, is it negative 9 or is it a positive 9? And the chart up above can certainly help you. On down to fractions here, okay? We've got a mixture of multiplication and division, and I'll say this right off the bat here. The nicest part about multiplying and dividing fractions versus adding and subtracting them, you don't need those common denominators. Oh, thank goodness. Okay, that's actually a theme that we'll see as we do more with addition and subtraction, and then move to multiplying and dividing. We'll see it when we get to variables. We'll see it when we get to square roots. When you add and subtract, there are actually more rules that you have to follow than when you multiply and divide. And our first introduction to that is going to happen here. So I made a little PowerPoint for you. And so let me, from the beginning here, okay? Negative 10 ninths times 3/5 is one of the questions on your page. So go ahead and find that. And we're going to talk about how to multiply these two fractions. If you look at the key points on PO10 for multiplying fractions, you see that I've written that you go straight across, okay? Again, we do not need those common denominators, so we can just go ahead and multiply 10 times 3 and multiply 9 times 5. And that's going to give us a 30, 10 times 3, 30 in our numerator, and 45, 9 times 5, in our denominator. Okay. The reason why this fraction is negative, you see it's a negative 30/45, is because the rules for negative and positives and negatives when multiplying and dividing is the same whether you're doing integers or fractions or decimals even or whatever. We have a negative fraction times a positive fraction. And so according to our chart up above, our product is going to be negative. Okay. But for that multiplying fractions, it's just going straight across. 10 times 3, 30. 9 times 5, 45. We can reduce that by dividing both 30 and 45 by 15, which, of course, you should. You know, you will not ask Mr. Olson if you need to end your sentence with a period on your ELA paper. Of course not. You always do, okay? You always simplify fractions. So negative 30/45 becomes negative 2/3. Another example, 2 1/9 times 5/9. So here we have a mixed number, okay? And similar to when we added and subtracted fractions, I recommend that you first convert that mixed number to an improper fraction. So that 2 1/9 we are going to rewrite as an improper fraction. So using our shortcut that we've talked about, 9 times 2 plus 1 gives us 19/9. We're multiplying that by our second fraction, 5/9. So convert 2 1/9 to 19/9, and we're multiplying that by our second fraction, 5/9. Because we are multiplying, what do? Straight across. In this case, our denominators happen to be the same, but that's just cool. It doesn't have to be that way. We didn't try and make it that way. It's just what happened, okay? So they don't have to be the same, but if they are, it's no big deal. 19 times 5 gives us 95. 9 times 9 gives us 81. Is there a common factor that we can use to simplify 95 81sts? There is not. So we leave it as is and we move on with our lives. Okay. If you want to convert that to a mixed number answer, will that be 1 and 14/81? That's totally fine. But improper fractions will become more and more common as we get deeper into pre-algebra and algebra. So leaving it as an improper fraction is just fine. Okay. But again, multiplying fractions, no common denominators necessary, multiply straight across. And if you do have a mixed number as part of your expression, do convert that to an improper fraction first. Okay. So let's look at division. One of them on your page is 15/8 divided by -3/2. 15/8 divided by -3/2. So two things here I want to point out. We do have a positive fraction divided by a negative fraction. So that should tell us something about what sign our quotient is going to have. A positive divided by a negative. We know our answer is going to be negative. Okay. And we also see that we have a mixed number here, -3.5. So similar to the last example, when you've got a mixed number, rewrite it as an improper fraction. So we get 15/8 divided by -7/2. And then -7/2 came from multiplying 2 and 3, and then adding 1, -7/2. Now we get some options here. If you look at your page at the key point, you'll see that there are actually two methods listed for dividing fractions. Okay, the first is called cross products. Notice how I'm connecting the 15 with the 2, and I'm connecting the 8 with the 7. And those two arrows make what looks to be a multiplication sign. Okay? And that's exactly what cross products is you are multiplying in a cross-like fashion. 15 times 2 gives us 30. 8 times 7 gives us 56. And you can see the 30 is the numerator of my answer. 56 is the denominator of my fraction. And just like before, if we can simplify, then we should. So divide 30 and 56 each by 2, and we get 15/28. And of course, that answer is negative, like we talked about earlier, because we have that positive fraction divided by a negative fraction. So we don't actually divide fractions per se, right? When we have a division symbol, we look for ways that we can kind of manipulate this so that we multiply instead. And one of those ways is to multiply using cross products. The numerator of one times the denominator of the other, 15 times 2, and the denominator of one times the numerator of the other, 8 times 7. And when you do that, when you draw those arrows in there, you see that multiplication symbol, okay, which might remind you to multiply. So -30/56, final answer of -15/28. The other method, which accomplishes the same thing. So now we are back to 15/8 divided by -7/2. Okay. Instead of using cross products, we can also flip that second fraction and change the operation to multiplication. So 15/8 divided by -7/2. Because becomes 15/8 times -2/7. We've flipped that second fraction, and we've changed the operation to multiplying. And now that we're multiplying these fractions, we think back to our examples at the top, and we remember that we go straight across. And so in both methods here, we end up multiplying 15 by 2 and 8 by 7. If we kind of leave it written as division, we use cross products to multiply the 15 and the 2 and the 8 and the 7. If we flip that second fraction, we change the operation to multiplication, and now going straight across, we're still multiplying 15 times 2 and 8 times 7, which gives us the same answers of -30/56, 15 times 2, 8 times 7, 30/56, which we simplified to be -15/28. So is it better for you to use cross products or to flip that second fraction and multiply? It's really up to you which one you use. Personally, I would recommend starting with the second method. And the reason for that is because, when you flip that second fraction and go to multiplying, then you can always be thinking, just go straight across, straight across. And it's very easy to see that 15 times 2, that 30, ends up in the numerator of your answer. As you get the hang of this a little bit and can possibly do it a little more mentally, you can go to cross products, and that this 15 times 2 is going to end up in the numerator of your answer, because that's where the 15 was. It depends on where that first fraction is. Then 8 times 7 gives you the 56. So it's kind of up to you which method you want to use. As you can see on your paper, I do require that you show your work. Write your answer in simplest form. I guess it doesn't specifically say show your work up here, but you're all hearing this, so show your work, okay? Especially with those dividing fractions. Show me whether or not you are using cross products or whether you are flipping that second fraction and multiplying, okay? So you've got a few integer things to do here, a few fraction examples to do. That pretty much wraps up the page. This is going to be due on Friday. Yeah, a couple other administrative reminders, football picks. If you are doing that, they are due tonight. They're posted in Google Classroom for that. Khan Academy is due tonight as well. You have literally the entire day to finish it, as it's not due until 11:59 p.m. And then new Khan will be assigned long after you've gone to sleep, and so you can look for that Friday morning. That about wraps up the lesson. So have a great day, folks. That is how you math. Bye. How do I turn this off? Oh, yeah. Here we go.